Welcome to the video on Chapter 3 Angles, Lesson 4, Adjacent Angles and Linear Pairs. By the end of the lesson, we should be able to identify pairs of adjacent angles. By definition, adjacent angles are two angles that have the same vertex and share a common side but no interior points. Here are three examples of adjacent angles. They have a same vertex. They're sharing this vertex here for angles 1 and 2. They have a common side, this ray right here, and there are no interior points. Same with angles 3 and 4. They share this vertex here and that common side of this ray here, and same thing 5 and 6. And my examples here are really just like, this kind of looks like a right angle, but it can certainly be acute. Like they can be acute angles that are split. It can be a straight angle that is split, and it can also be an obtuse angle that is split. And notice that at this point I'm not saying anything about being split in half. Hopefully it's obvious that in this example, angle 4 looks to be acute and angle 3 is obtuse. So it's not splitting in half, it's just that they are next to each other and they share this common side, that ray there. And now these some non-examples, angle 1 and angle 2, though they are next to each other, they do not share a common vertex. Same thing with 5 and 6. And 3 and 4 look like that if you smash them together would be pretty similar to 1 and 2, but they don't even share a common side at all. So these are non-examples of adjacent angles. These are adjacent angles. Moving on to a linear pair. A linear pair specifically is two adjacent angles that form a straight line, which means that they will add to equal 180 degrees. So an example here, very similar to an example we already had with adjacent angles because they are adjacent angles, two adjacent angles. And this non-example here, though there is a straight line, there are three angles, so we cannot call them a linear pair. Okay, we'll get into another word for what it means when they add to equal 180 degrees, any number of angles, but specifically when it's two, they're called a linear pair. Looking at this example, we are asked to name all linear pairs, keeping in mind that we need to be creating a line here. So the only line that I see a bunch of rays, but the only line that I see is actually line NC or NB, whatever you want to call it, this line here. Okay, the rest of them are rays. So this is the line that we are trying to create pairs on. One set of linear pairs would be angle NBA and angle ABC, sharing this common side of ray BA. And using that same example, another set of linear pairs would be the angle NBL and LBC, where they are sharing this common side of ray BL. So notice in this example, we're ignoring this ray BA, and in the green example, we were ignoring this ray of BL to create the linear pair. Let's take a look at an example that looks a little bit busier as far as our linear pairs and our angles go. I see a couple of lines here. We have a line KRH. We also have a line VRT. So that's something to keep in mind, that this RO ray is not actually creating a line as it only goes on forever in one direction. So let's take a look. We're going to name all angles adjacent to angle HRT. So angle HRT is highlighted, but adjacent to that would be ORH or HRO, if that's what you want to call it. That's, remember, you have those options there, but it is touching HRT and has this common side of RH. Same thing over here, TRK or KRT. That angle is also sharing this ray of RT with HRT. Next question is asking to name the angle that forms a linear pair with angle VRO. So we're looking at VRO and we want to form a linear pair, and it's just one angle for this one. So again, in this problem, we are finding a linear pair with angle VRO. which is located right here, highlighting that in green. It's angle VRO. The linear pair means that we needed to create a line. The only one that creates a line is angle ORT, because there's that line there that creates that 180-degree line. So angle ORT or TRO would be your choices for the linear pair. Let's go ahead and take a look at the final question. Two angles that form a linear pair with HRT, keeping in mind here that HRT is here, and we now want two angles that will form a linear pair. So two options as opposed to just one with angle VRO. So two angles that are a linear pair with angle HRT, they're highlighted in blue. Remember, there are two lines in this diagram, so we're going to be looking for two linear pairs. First one will be on the top left there, angle HRT, because it creates that 180-degree linear pair there. It's creating that line, and we are ignoring ray RO. So angle VRH or HRV. The other option is angle TRK, because that creates the second line 180 degrees over there, where we are now not ignoring any ray in that case. So angle TRK or KRT would be the other linear pair with angle HRT to create a second line. Go ahead and take some time to do the next couple on your own with that 1, 2, 3, please. Here are some answers for the practice 1, 2, 3. One angle that forms a linear pair with angle TMB. TMB is here. BMJ is one angle that forms a linear pair. Because it is TMB, there is no other line that's created, so you have to use this linear pair here. You can't go the whole way around because that's more than a line. So only one angle here. Two angles that are not adjacent to angle JMX. I wrote down angle HMT and angle TMB. And three angles that are adjacent to angle BMX. I got angle XMJ, angle BMT, and angle BMH. So that's concluding this lesson 4 video from chapter 3 on adjacent angles and linear pairs.